Bismillahirrahmanirrahim. So this is the settings.py file, and in this file there are configuration. This file configures the whole systems. For example, the data paths, the categories, exact matching, keyword list, normalization method, missing value strategy, and month orders. Basically, this file contains all the global settings. Anytime I want to change categories, mapping rules, month, order, or normalization, I change it here. I'm going to show you the categories which I have mentioned here. For example, the subcategories which I mentioned in the assignment, or sorry, the project, and the subcategory keywords are mentioned here. And these are about the months and the normalization methods, etc. etc. Now moving to data loader. So the purpose of this file is to load data with the data which was given to us, the XLSX file. So this file loads the dataset, validates sets, and returns a clean data frame. It is the starting point of all pipelines. And if with the data which was given to us, the XLSX file. So this file loads the dataset, validates sets, and returns a clean data frame. It is the starting point of all pipelines. It is only loading 2023 data. So moving on to the next file, which is similarity engine.py. So basically what this file does is, let me click this off. So basically what this file does is it computes cosine similarity between cities for each year wise and category wise. This file transforms the monthly vectors into similarity matrices. It tells me which city behave similarly in terms of price movement. If I can run it individually, wait for it. I think I would need to make another file. Clarity. Wait, I can run it here. Wait. Yeah, no. I have run this file individually. So basically what this does is like it gives me, so basically Panda only shows the 5 columns. So basically if I run without Panda, it will show all 17 by 17 vectors. So this shows a similarity between the cities. Now moving on to the next graph, which is graph builder here. So basically what this file does is it creates network graphs from similarly matrices. For example, the weighted graphs and the threshold graph. This file converts similarly matrices into an actual network where cities are nodes and similarities are edge weights. So if I can run this graph, I'm gonna update this file and let's run that file. Now it will show me. Wait. This is so basically it gives the output like what things are and how they are organized. So moving on to the next file, which is centrality. Yeah. So basically what this file does is it calculates which city is most influential, most connected, and most central in CPI networks. And we can also test this file, but we are short of time, so we're not going to do that right now. I will show you the whole project which you later on. So let's go to the temporal relation. So what this does is, this is the time-based analysis. This does time-based analysis. It checks how city evolved from 2023 to 2024 and then to 2025 and builds a partial order structure. Moving on to the next one, which is run temporal, which is this here. So what this file does is, this script runs the entire temporal analysis and exports all files: similarity matrices, partial orders, growth, vectors, and Hesse diagrams. So if we and if we go to visualization, so this is the back end of the whole project. This file visualizes each and everything: the graph, the Hesse diagrams, each and everything, the similarity graph, this contrariety, something, all kind of things. This file is responsible for it. And this file is the backend driver for all visualization generation. The GUI calls these functions from this file. Moving on to the graph plotter from visualization. Here, graph plotter. So basically what this file does is it uses a networkx plus matplotlib to visualize the city similarity networks. And so basically in visualization, these are like just the hollow pieces of files which do something, but they are not directly connected to core files, but they are connected to like analysis files, like visualization. These are all connected to visualization file. So visualization files contacts them, and then it makes something. The Hesse diagram is the same. Sorry, not this one. We will go to centrality. This one. So what this file does is it plots central values as a bar charts. I'm going to show you bar charts like here. If you go to here and this between is like the centrality between closeness and degree centrality and eigenvectors, etc. This file is responsible for creating the bar charts. Moving on to the next, which is temporal visualizer. This file is responsible for creating the Hesse diagrams. So let's take into temporal Hesse diagrams. Just like these diagrams, it will create diagrams like this. And moving on to the last file, not last file, only one is remaining, which will be not this. Similarity actually. Yeah, I actually got the file now. The last file is GUI main. So this file, I'm gonna show you how it runs. It will open a terminal right now. Let's wait. So in the meantime, I will explain what this file does. This is the GUI that sits on top of the entire project. It has multiple buttons, multiple backend pipelines and threads. So this is the file which has opened now. So we can load like custom file, whichever file we want to load, it can load it, and we can commute similarity graphs. It will take some time. It will gonna commute the similarity graph. I had already commuted them, so it's gonna take some time. Okay, it has successfully commuted similarity graph. Just like similarity graph, we can opt for centrality. Again, it's gonna take some time. It's gonna like display the text when it is done. In the back end, I'm gonna show you what's going on. Okay, no, it's not shown here. Yeah, it's done. Now go to temporal visuals. This is just warning. This is not just a warning. This is just warning, not actual error. I'm gonna show you where it did. They will be creating visualizations.output in the output. Yeah, here they are being created. Here is a similarity like a CSV file and all the stuff. This is the heat map which was created. We can zoom it, zoom in. We can see what is actually going on in this and this. They're almost the same because I have multiple times right now. So because since the data is the same, so it is like putting the same thing again and again. This is the graphs for like wait, I'm going to change centrality thing. It's about a closer, but it's of the same year, like okay, year and category. So I think it's going to be XYZ. In the conclusion, I want to add that my project is modular. It can run individual components manually before launching the GUI. Each file handles one part of the CPI network analysis system: pre-processing, similarity, graph building, centrality, temporal analysis, and visualization. The GUI simply provides a user-friendly interface to trigger these pipelines. Thank you.